So now that we have processed our big brain block and produced our histogram file, which is stored in this txt file, we're going to upload these data sets back to DataLad. So, that could be an example if you're doing whatever processing on your end and you want to contribute it back to the archive, you could use, for instance, that functionality. So you may have understood that actually DataLad is not a storage location. It's a protocol, it's an interface to access multiple heterogeneous storage. So when we say we want to add derived data to DataLad, we actually have to first identify a storage location. What we are going to use in this activity is the Open Science Framework. For those of you who don't know, the Open Science Framework is one of the main archives for research data. So it allows you to upload your data as long as it's not too large and to associate permanent identifiers to it. It's very much equivalent to the Zenodo platform, which is based in Europe. So DataLad interfaces with the Open Science Framework. So data which is stored in OSF can be installed and retrieved in DataLad, and conversely, data which is accessible by DataLad can be pushed to the OSF. This is actually a recent feature that was brilliantly developed by Michael Henke and colleagues in the last summer at the HBM hackathon, starting at the HBM hackathon. The first thing we want to do is to actually save our histogram file in our DataLad dataset. So remember, we created there a dataset called histogram, and we changed directory to it. So you can do, many things there, add files using whatever application. Turned out we used boutiques, but maybe you're using SPM or you're using, I don't know, something else, and you just created a bunch of files resulting from your processing. So when you run DataLad save, it will commit these files to the DataLad repository. If you know Git, this is very much equivalent to a Git commit. This operation is distinct from file creation because, some files may have been created by mistake. You may not want to commit everything. So, sometimes there is cleanup involved, or, you just want to save the last attempt, the last successful attempt after a few other trial and error. So now we have a clean DataLad dataset, located in under our histogram directory. This dataset contains actually the boutiques invocation that we used and the histogram file itself, the txt file. To upload our newly created dataset to OSF, we will need a particular token, which has to be associated with your OSF account. Just for the sake of the demonstration, I'm going to send you a token which is linked to an account I created for this tutorial, and I will put it in the chat so you can use that. If I can find the chat. Sorry. Okay, so this is the token. It doesn't look great, but it's you don't have to remember it. I mean, it's automatically generated from your OSF account when you create an OSF account. And you can revoke. The main point is that tokens can be revoked. So at some point, if you created a token and you don't want to use it anymore, or for instance, I could revoke this token after the tutorial so that you only have temporary access to my account. If I run this cell, this actually creates in DataLad jargon what's called a sibling. A sibling, like a clone of the datasets, a mirror of the datasets in OSF. And you see the OSF datasets, is accessible then through this URL that you should see appearing in your notebook. If I click on this link, it will show you the newly created dataset on OSF, BigBrain histogram. You can check the dates to make sure that it's consistent. It has a few tags by default, but you could add more tags if you wanted to make your dataset searchable. In particular, if you want your dataset to be added back to the Canadian Open Neuroscience platform, you can just add a specific tag here, Canadian Open Neuroscience platform, and then your dataset will be discovered by the CONP and added. The only thing that you may have noticed is that this dataset is actually empty for now. It's just an empty dataset. There's nothing in there. So that leads us to the last step of our tutorial, where we actually need to push the data to the dataset. Again, that takes a token that you have to replace here. And once this is configured, you can execute this cell. It will take a little bit of time. There's quite a bit of communication going on. And when this successfully completes, we should be able to see our histogram data now available on OSF for everybody to use. Just a side note there, it's called the Open Science Framework and the Canadian Open Neuroscience Platform, but it's also possible to have private datasets there and to configure access permissions. It's easier, and these platforms have been made for public data sharing, but it's always possible to customize them for whatever reason so that data is not accessible by anybody. So the upload is now finished. If I refresh this page, I'll see now my data set has a bunch of files, and in particular, the histogram file that I created, which we can access through the OSF interface, and the boutiques invocation, which describes what were the parameters that were used to generate these files in case, anyone wants to reproduce the computation. All right, that concludes the first part of the tutorial. I'll just take maybe 1 minute to look in case there are any pending question in the shared document. Doesn't really look like it. So in that case, okay, yeah, Xiao is asking, the data is being pushed to osf.io. Absolutely, Xiao. This is like the two last cells actually pair your local copy of the dataset to osf.io to my demo account there, but you could reproduce that with your own account if you wanted to, and it pushes the data there. There's a question by Elena, what exactly is this a histogram of? So that leads me back to the processing part of the tutorial. Here we just used, actually, when we executed these commands, we just used FSL stats to compute a histogram of the 400 micron volume of the big brain. That, I mean, it's not really made to be pointful. I mean, it was just an example of processing and to illustrate how data can be processed. All right. Okay. I guess that's it. Or maybe one last question from Mash Bayar. What's the advantage of using boutiques tools to process instead of other tool libraries? So, I mean, you can use other libraries for sure. If you paid attention, you could see that nothing really in the DataLad part was specific to boutiques, and that's by design. You can run any, your preferred command line tools, produce any file, and then add them to DataLad, no problem at all. What boutiques provide is a consistent interface of containerized tools. So in boutiques, what runs here, all the tools that you can search and find in boutiques can be run on any computer that has a Docker or Singularity engine installed. In particular, this is true of most HPC systems these days. So if the tools are in boutiques, you can run and prototype on your local computer and then run on HPC system using exactly the same installation without having to worry about different versions, and spending time on installation. In the second part of this tutorial, Natacha is going to illustrate exactly that. We run the same processing, but now in CBRAIN on an HPC system.
Yeah,
Jemal is asking, ask your instructor. Absolutely. So that's because to push data to OSF, you need a token. I didn't want to put this token like publicly in a notebook. That's not really great practice. So I pasted the token a few messages up in the chat. I can do it again. So you should replace this string saying ask your instructor by the content of the token. So just, and you should obtain a command like the one which is on the screen now. Okay, I guess that's a wrap. I will hand it over to Suzanne. Feel free to reach out to any of us if you have any question.